Hi, this is Sam from exampa.net. Fit Marionberry, you asked an excellent question regarding the June 18th SOA solution. I wanted to just record this quick video to show you what I noticed that I think will help you. So it seems like your main question is, when a model has an AUC of 0.5, like the ROC curve runs along the diagonal shown, its performance is no better than randomly selecting the class for new data such that the proportions of each class match that of the actual data. You say, my understanding of the ROC curve with AUC of 0.5 is that it represents the performance of a model which randomly classifies observations in proportion to the value of the cutoff, irrespective of the proportion of the actual data. So that is saying that you randomly classify a proportion of observations equal to the cutoff as false and the remainder as true. I think that this is somewhat of a misunderstanding because it's not correctly understanding how you calculate the AUC. So consider this interpretation. The AUC is the expected proportion of positives that are ranked before a uniformly drawn negative. In the case of this, it's a positive is a person who purchased the insurance product, and a negative is the person who didn't purchase the insurance product. So if the AUC was 0.5, it would mean that the probability that a randomly chosen purchaser has a higher predicted probability than a randomly chosen non-purchaser. The way to calculate the AUC is is actually to measure the class separation. So the AUC is a measure of how well you divide up the people who purchase insurance from the people who don't purchase insurance. So on the left here, you see these are purchasers. And these on the right are non-purchasers. And then you create a cutoff value like this. And so on the y-axis, you see the percentage of people. On the x-axis, you see the assigned model probability that goes from 0 to 1, right? So you can think of this as being a histogram, like where each point on this histogram, right, is a customer. And so when you create this histogram, you divide up purchasers from non-purchasers. And then for each person, you know the model's probability, right? It's either point. So like this person way over here might have probability of purchase 0.1, whereas this person all the way over here has a predicted probability of 0.98. And you know from the actual data that this person actually purchased and this person didn't. Maybe it's easier if I use different colors. So this curve, what you'd call blues, are people in the data who purchase, and the people in the data who don't purchase are these greens. And then I'll link to you another video which I found really helpful. And essentially they draw a picture like this, where the sensitivity is just the area under this curve here. So these are all people who were true positives. That is, they purchased the product and they were predicted to purchase the product. So if you look at this area, this is the sensitivity. And then if you look at the area to the left here, this is the sensitivity, the specificity, and then 1 minus the specificity represents this graph right here. And so your ROC curve shows the graph of this false positive 1 minus specificity versus sensitivity. And so that's how you calculate AUC. So you necessarily have to split up your classes. And so that implies that you need to have the same proportion of customers as in the original data. Let me go back to your question. See, irrespective of the population of the actual data, because that doesn't make sense, because in order to create this type of graph that I just showed, you need to have the correct labels, right? Purchasers and non-purchasers. So I'll link to you the video, and a good way to remember this, I think, is just looking at these pictures. So an AUC of 0.8 would be that there's some class separation, right? So the reds would be non-purchasers, and the blues would be purchasers. And anyone to the right of this line would be predicted as purchasing, and anyone to the left would be predicted as not purchasing. And if you looked at the ROC curve, this is 1 minus specificity, and then this is sensitivity on the y-axis. If you have an AUC of 1, it means that you are perfectly separating the classes. That is, all the people who purchased are predicted as purchased, and all the people who don't are predicted as not purchasing. And this ROC curve is basically has an AUC of 1, because it's the area of this square is 1. And then if you have a very bad model, then your AUC is about 0.5, which means that there's very little class separation. And that's what it looks like. Finally, in R, you can actually experiment. So I have the question open right here, and I've written some code which basically randomly choose customers as 0 or 1 in the same proportion to the actual data. So I don't need to go through the details of how this works, but basically the gist of it is that if you do that, then you get an AUC of about 0.5. 0.4974. So that's just a way of verifying the logic behind your model. I hope that this is helpful. We're in the process of creating more tutorial content that's based on the June 2020 exams. And so if you sign up for our course, you'll get access to in-depth lessons just like this one, as well as a lot more that's coming in the weeks remaining up to December 7th.